Okay, I know that going over all three different conic sections today was a whole lot, so I'm gonna break it out into 3 different videos and do some of the homework papers, the handouts that we did. I'm gonna walk through those to better explain, and then also kind of going over the teaching textbooks. You are more than welcome to do the teaching textbooks videos and lessons and the problems that are affected with it, or you can just read your textbook. It does explain through the process of each of them. Some of the times it will skip some steps of the work, but at least it does give you another chance to read if you need to see in person what it is. So for the circles, for teaching textbooks specifically, that is lesson 77. But it is also lesson 82. So lesson 82 needs to go with lesson 77 because that's the distance and the midpoint formula, which specifically goes with circles. So make sure that those are combined together when you do that. So let's go over a couple of things about circles. So one of the things that I was explaining about circles in class is that if you have a graph and you have a circle, that our rate of curvature, if we were to divide this circle where I have a parabola here, and actually if we work it out and the radius is 3, then this if this is actually the y and the x-axis, if we had our radius 3, this bottom parabola right here would be y is equal to 1/3 x squared minus 3. Okay. And then this top one would be y equals negative 1/3 x squared minus 3. So see, as we're looking at the individual sections, we can graph the individual parabolas. Now, if we choose instead and we look sideways, so we're going from here, this is now our vertex. So now this is an x equals 1/3 y squared minus 3. And this one is an x equals negative 1/3 y squared minus 3. So as we can see, depending upon where you're looking in your circle, your rate of curvature, which is that a, that coefficient, is the same for all of it. That is why on a circle, you have x squared plus y squared equals your radius squared. Okay? Because our rate of curvature is going to be exactly the same no matter what little section we are taking out. Okay? So this is for one at the origin. So let's look over in the teaching textbooks. If they're talking about graphing a circle, they give you the equation. They show you how to graph it if it's at the origin. Whenever it's pulled off the origin, when we don't have numbers, it is just like our parabola where we add that number to our x and our y. But we are going to add it within the squared, so it's the whole section squared. This is talking about the whole section of x, the whole section of y, and then your radius is the same. So given our formula, if we were to have this problem here, it says select the graph of the two variable equation x squared plus y squared equals 4. What we want to be able to do is look at that equation and say my x is completely by itself here. My y is completely by itself. There are no extra numbers. So automatically we know it's at the origin. So it cannot be any of these graphs. There's 2 squared terms, so I know it's a circle. So that takes out that one. There's nothing added to your x and y, so it immediately takes out that. So if we're looking at this, we are already down to only a and b. So the difference is that the number at the end is your radius squared. So 4 is equal to your radius squared. So 4 cannot be the radius. 4 has to be 2. So 4 can't be this one. So by default, it has to be A. So just looking at this equation, we can find the graph. Let's look at this one. X minus 2, y minus 4 all squared, and then we've got 36. So right here, I have something added to the x, I have something added to the y. So I automatically know it is not at the origin. So we have to take out number C, letter C, because it's not at the origin. So what could it be? We know now that the x value would be 2, the y value would be 4. So I've got a positive 2 and a positive 4. Remember, it is the opposite of this sign because we are setting these equal to 0. Okay? So since it's a positive 2, 4, then this one is also not valid. And this one says 4, 2, so it is also not valid. So we're down to A and D. Both of these have a center at 2 and 4. We know that 36 is our radius squared. So the square root of 36 is 6. So at this point, I would need to add 6 to any of these numbers. So 2 plus 6 gives me 8. 6 plus 4 gives me 10. Excuse me. On this one, I would need to go 2 plus 8 equals 10. So it's not B. So we would have A. So just from looking at our equation, we can figure out our graph. Okay, so looking at number 6 down here where it says tell the center and the radius of the circle. The center are the numbers that are added. So our center is going to be 6, 7. The radius, oh, this one is already in a squared term, so your radius is simply 12. Now, so that's how working through these problems. Let's look at what I gave you also combines lesson 82 because we have the distance formula and the midpoint formula. So you can go to lesson 82 to see more about that. Remember, our distance formula comes from the fact that we have a center and we have any point on this circle, okay? From the center to any point on the circle, we can make a right triangle. And the radius here is the C portion of our Pythagorean theorem that says A squared plus B squared equals C squared. In this case, we have A and we have B. To find our A, it is the difference between our X value of this point and our X value here, because if we were to drop it down, so we were going from X1 to X2, we would need to find the difference there to find A. Here we're going from Y1 to Y2. We would need to find the difference of B. So all of that is translated here. So here is our difference from X2 to X1 gives us A. So this is really A, which makes it A squared. The difference between our B's is Y2 minus Y1. This is our B. So we have B squared. Our D is our distance, which that's the same as our radius, or our C. So A squared plus B squared equals C squared, right? Because that would be over here. But we don't want to have the C, so we took the square root of both sides. So that's where we get our square root. So our distance, or our C value, ends up being the square root of A squared, this is it broken out, plus B squared. Okay, so there's our distance formula and how that breaks out. Okay, so on this one, if we were to graph, oh, I think we did that one in class. Let's do 3. We initially need to move our X over. So we need to rearrange our equation where both values are on the one side and then our number is on the other side. So now I have X squared plus Y squared. There is nothing added to my X, nothing added to my Y, so I know my graph must start in the origin. My radius is the square root of this number, since it's not already set in squares, so my radius is 2. So if we did 1, 2, I'm doing 2 blocks per one, then I would go 2 on all sides and I would graph it. Okay. So let's look at the back one. When we are given a center and a point, to find the radius, we need to find the distance of it. So this is the one that we worked out in class. In the same way on this one, our center is -1 plus -2. So immediately we can go ahead and plug in 1 here because this makes this -1. We can make our Y value -2. So I'm going to do +2. So my left side is already taken care of. I just need to find the distance between these 2 points. So we're going to take the square root of the difference. Remember, whatever one you choose to be labeled as 0.1 and 0.2 has to stay in order. So in this case, we have 2 minus a negative 1, which makes it 2 plus 1. We have negative 1 minus a negative 2, negative 1 minus a negative 2, which makes it negative 1 plus 2. So now I have 3 squared, and I have a positive 1 squared, which gives me the square root of 10. So your radius is the square root of 10. So here, remember, this is our radius squared. So you could have done square root of 10 squared. The other way to write it is to just go ahead and write the 10. Okay. So then when we are going from our equation, when we're started with the equation first, and we need to get it into our vertex form, we're going to group our x's together. Just like here, we grouped our x squared and our 4x together. We left a space. We're going to group our y's, and we're going to move our 5 over. So group our y's, leave a space. We complete the square. So we do half of 4 is 2. 2 squared is 4. Whatever I do on the left, I do on the right side. We're going to do half of 8 is 4. 4 squared is 16. Put 16 there. I'm going to add 16 on this side. Now I can rewrite this section as a square, x plus 2 squared. We're going to rewrite our y's as y minus 4 squared. We add up all these numbers and we get 25. So now we have our graph that we can graph. We know our center is at negative 2 and positive 4. We know our radius is the square root of this number. So our radius is 5. Then you would need to plot it.